Okay, so we're going to be doing experiment 1, starting off in your lab packet on lab number 5 today. And we're going to be looking and trying to understand is a thermal halide circulation. And so first we're going to try to understand density differences. As you've seen in our lab, ocean circulation, deep ocean circulation can be driven by differences in density, which density is going to be affected by the salt content and the temperature. So the first lab, experiment 1 and 2, we're going to look at temperature differences. So as I have right here, I have a mason jar filled with just room temperature tap water. And what I have right here is very warm water that I put red food coloring in. So I boiled the water and I put it in here. And if you do this at home, you have to add it very small amounts at a time. I'm actually using a squirt bottle. And so let's see what happens when I put this very warm water into the room temperature water. So I'm just going to put a little on top up here. So I can see it's mostly staying confined to the top. It is sinking a little bit, and that's probably because it's starting to cool off. But as you'll see, it is going to be more confined to the top of the water. Put a little bit more into there, and as it cools down, it will eventually fall to the bottom. But that can give you a good idea of like the hot water and where it's staying right now. Put a little bit more into there. Okay, so this is hot water into room temperature water. Okay, now I have very cold water. This water wasn't ice water. I put blue food coloring in it. And again, we now have room temperature water in a mason jar. And you can, again, you could use any kind of glass you have at home. Just when you pour the cold water in, make sure it just pours just a little bit at a time. So this is very cold ice water into room temperature water. There's a pretty large difference between this one and the hot water I put into room temperature water. Okay, so yeah, so you have some glasses at home and some food coloring, you can do this experiment yourself, but this is just to give you a little idea of how you do it, and you want to pour a little bit at a time. Okay, so for the last part, we're going to be looking at salinity density and try to understand why maybe some solutions will have more salinity than other solutions, and we'll see what that does. So again, we have 2 room temperature mason jars full of just room temperature water, and then we have 2 glasses over here. Again, about half full, maybe a little bit more, with room temperature water. So what you want to do, what it calls for the first solution, you want to put about 1 tablespoon of salt. So I'll fill about 1 spoonful. A little bit more right there. So there we go. It's about right there. 1 spoonful. And then for the other cup, you want to put a little bit more in. So put 1 in, and then we'll put 1 more. Again, this gets a little messy, but that's okay. Okay, so we'll call this solution A on my left. Solution A, solution B. To help you see this a little bit differently, we put a little bit of food coloring in. One drop each. So there's no difference in the food coloring between the cups. And again, you can pour this in slowly So I'm going to use a little pipette. It's a little easier to pour it in. You can see it. Again, if you have a little pipette at home, you can. Maybe use for baking, or you can just slowly pour it in slowly at a time. There we go. Okay, so if you can't see it clearly, I'll tell you how long it takes to get to the bottom. So here's the solution A. 1, 2, 3, 4, 5, about 5 seconds. One, 2, 3, about 3 seconds. It's a little hard to see, but solution B sinks to the bottom much faster than solution A. And solution B has more salt than solution A. So if it's not clear from here, that's kind of what you should see. So just know solution A is slower than solution B. All right, so just I hope you get a little better understanding. Maybe you can do a setup a little better. This is just a rough little kitchen scientific setup.